Here we look at an introduction to ionisation energy. You've got a definition for ionisation energy there. The energy required to remove a mole of electrons from a mole of gaseous atoms or ions. Now, it's very common that an exam question could ask you what is the definition for the first ionisation energy. That's the energy required to remove the first electron. And that would be the energy required to remove a mole of electrons from a mole of gaseous, and here we'd have to say atoms. So it's also common for the exam board to ask you to write an equation for a particular ionisation energy. And the first ionisation energy of sodium, the equation for that will be as follows. Now, if we can see from this definition, it has to be gaseous. So I have to include state symbols. And that forms my sodium 1 plus ion. And that there would be my first ionisation energy. The energy required to remove a mole of electrons from a mole of gaseous, and in this case, because it's the first ionisation energy, atoms. The second ionisation energy of sodium would be the energy required to remove the second electron. And the equation here then would be Na plus, again we have to put state symbols in gas to form a sodium 2 plus ion, and again plus an electron. Now the second ionisation energy will always form a 2 plus ion. So in effect, what we're saying is that this number here, this number here will always match this number here. So the third ionisation energy of sodium would form a Na3 plus ion. Now, a few things to note. The first, the ionisation energies are always endothermic. So ionisation energies are always endothermic. It requires energy to remove this electron. Energy must be put in to remove the electron. They've got a positive delta H. What factors influence the ionisation energy value? Remember, the bigger that this number is, the more positive this number is, the harder it is to remove the electron. So what factors influence this ionisation energy value? So I'll say again, the more positive this number is, the harder it is to remove the electron. Okay, so the factors that affect ionisation energy are, well, the most important factor is the energy of the electron. Now, what that means is really what principal energy level and sublevel, okay, the electron is removed from. That's what I mean by the energy of the electron. What principal energy level and sublevel is the electron removed from? And usually the higher in energy that the principal energy level and the sublevel is, then the easier it is to remove, and the lower your ionisation energy. The second factor is nuclear charge. Nuclear charge is only ever really a factor if this is constant. If the electrons are removed from the same place, then nuclear charge becomes a factor. And the other one is shielding. And that is where the electron remove is being shielded by the inner electron shells. The effect of the nucleus attracting the electron is being shielded, is being minimised by the inner electron shells. And we'll discuss each of these factors in more detail when we look at some individual examples. So that's a little bit of an introduction to ionisation energy. You certainly do need to know how to write these equations. Remember that they always need state symbols, and you may be asked to define First ionisation energy, which would be this definition, but you would actually say the word atoms in there.